Alright, you guys, I wanted you to have some example problems for your worksheet to help guide you through the process for the remainder of the worksheet. So that's what this video is about. Look at your first page, and the first example is for simple molecules, and it's H2O. So again, doing the same process as in our notes. What we are going to do first is calculate NAB and L. Remember that the N is the needed. So we have 2 hydrogens. Hydrogen is one of the exceptions, so it only needs 2, which gives us a total of 4. We have 1 oxygen, which needs 8. So we end up with a total of 12. Then we're going to look at the A column, and we're looking at valence electrons. There are 2 hydrogens that have 1 valence electron, gives us a total of 2, and the oxygen molecule has a valence electron number of 6. So we have a total of 8 available to us. Next, we're going to look at the B, and in order to calculate B, we have to take the 12, which is N, and subtract from that the 8 from the A column. When we subtract that, we get a total of 4 electrons involved in bonds, and that makes up 2 bonds. And then finally, looking at the lone pairs, we're going to take 8 and subtract from 8 4, and that is going to give us 4 electrons involved in lone pairs, and there will be 2 lone pairs. Now we're going to organize or arrange our Lewis structure. Remember, it said the least electronegative, usually the one written first, but not hydrogen or any halogens. So since hydrogen is the one written first, it only leaves O to be in the center. And then we will bracket oxygen with the 2 hydrogens. The next step is to connect and then verify the number of bonds written is the number of bonds we need. And we have 2 written, we needed 2, so we are done with that. And then the lone pairs, we are going to, we have 2 of them. We know that hydrogen is done. After we put a bond on hydrogen, we will not do anything else with hydrogen. It will not get any dots or any more bonds. So all we can do is place the remainder of the lone pairs on the center atom, oxygen. And then you also have to name this molecule, and it's called dihydrogen monoxide. Our next example is this molecule here. We have 1 carbon. Let me change the width of that. We have 1 carbon with a 4. Oh, sorry. This needs 8, which gives us a total of 8. We have 2 fluorines. They also need 8, and 2 chlorines, which also need 8. We add these guys up, and we get a 40. When we calculate A, we're looking for the valence electrons, which is what I tried to do earlier. So carbon has 4 valence electrons. We have 2 fluorines, and fluorines have 7 valence electrons. And we have 2 chlorines, and they have 7. So that gives us a total in this column of 32. Now remember, calculating, we need to take N and subtract from N A, and when we do that, we are left with a total of 8 electrons involved in bonds, and they will make up 4 bonds total. A minus B will give us a total of 24 electrons involved in lone pairs, which makes a total of 12 lone pairs. Alright, so now to get our structure, anytime carbon is present, it will be in the center. Because we want it to be balanced, we'll go ahead and put the fluorines in one direction, and then we'll put the chlorines in the other. You could flip-flop that, as long as those you have a symmetrical pattern. We're going to connect those all with bonds and then verify the number of bonds written is the number we need. We have 4 written. We needed 4, so that's good. And then the last thing we'll do is to draw the lone pairs. Now, we look at the surrounding atoms first. We see that fluorine only has 2 electrons right now, and it needs a total of 8. So we're going to place 3 lone pairs around fluorine, which will give it the total of 8 that it needs. We look at chlorine, we see it has 2, but it needs a total of 8, so we need to place 6 more, which would be in 3 lone pairs around each of the chlorines. And then we would check that the octets are satisfied, and they all are. Next, we're going to practice those multiple bonds, and remember that means that there's going to be, for at least one atom, more than a single bond present. We're going to do all the math the same way. So we have 1 nitrogen that needs 8. We have 1 oxygen that needs 8. And we have 1 fluorine that needs 8. We add all of these up for a 24. Our nitrogen has a valence electron number of 5. Oxygen, I'm not sure what's going on, there we go, has a valence electron of 6, and fluorine also has a 6. Sorry guys, fluorine has a 7. Let me see if I've got an eraser. There we go. We'll start that one over. Okay. Alright, so has 7. There we go. When we add that up, we get 18. Alright, so we have 24 minus 18, and that gives us a total of 6 involved in bonds. There will be 3 bonds. Then we've got our 18, and we're going to subtract 6 from that, and that gives us a total of 12 involved in lone pairs, and there will be a total of 6 lone pairs. Alright, when we look at this, we're going to place the first element provided in the compound first, and then we can just put our O and our F beside that. We're going to connect with bonds and then verify. We have 2, but we needed 3. So then we have to look at what we're given, and we know that the halogens cannot have more than 1 bond, and fluorine is a halogen, so we cannot place that second bond there, so we are left with oxygen. Our lone pairs, we have a total of 6 lone pairs that we need to do, so we're going to look at our oxygen, and we see that with the bonds, oxygen already has 4, so we're going to give it a total of 4 more by using 2 of our lone pairs. And then our fluorine, it has a total of 2 with the bond, so it needs 3 sets. That gives us a total of 5 lone pairs that we've used, so we'll put the last one above our center atom. And then you've already had the name on your worksheet. So our last example, calculating N, we've got 1 sulfur that needs 8, and we've got 2 oxygens that need 8. We add these up for 24. We have 1 sulfur. Sulfur has 6 valence electrons. We have 2 oxygens, which have 6 valence electrons. And we add these up for 18. 24 minus 18 will give us a total of 6 electrons involved of a total of 3 bonds. And then we have 18 minus 6, and that gives us a total of 12 electrons involved in lone pairs, and there will be 6 lone pairs when we divide that by 2. Alright, so we're ready for our structure. You'll notice that S is written first, and then we have 2 O2s. They're all in the same group So since we want symmetrical, it makes more sense to put the S in the center. And then we're going to bond. We need one more bond according to our B column. And it really doesn't matter which O we place it on. So just pick one of those for your third bond. Now our lone pairs, it will determine, or they will be determined by how many bonds are already connected. So if you followed my pattern with the double bond on the left, you will notice that so whichever one you have double bonded, it already has 4 electrons, so it only needs 4 more. And we'll use 2 of our lone pairs to give it that. And then our other oxygen will need 3 sets to give it a total of 8. So we've used up 5 and we have 1 left, so that gets placed on the S. And then the name of this one is sulfur dioxide. I tried to make this video short and sweet, give you the practice that you need, or so that you can verify your answers to this one. And you can watch this over and over as many times as you need to help you complete the rest of the assignment. I'm out. Thank you much.